Alright, this is Geometry, Section 1.5, Exploring Angle Pairs. The essential question is, how can you use a special angle pair to find angle measurements? And let's go. So I took this from the book. It's a nice table that talks about different angle pairs. I think the diagrams and all the information helps you out, so write what you need from that. But let's go through it. Adjacent angles. These are angles that have a common side right here. So this side for 1, 2, or this side for 3, 4. They also have a common vertex right here and right here. And they have no common interior points. What that means is the angles aren't inside each other, they're next to each other. So like if you had an angle like this for 1, 2, kind of like up like this, that wouldn't work. This wouldn't, and we call that angle 3. 3 wouldn't be adjacent to angle 2 because we can't put an angle inside another angle. That doesn't make it adjacent. Next one, vertical angles. We talked about a little bit of this in class. They're angles whose sides are opposite rays, so kind of like opposite angles in a way. So 1 and 2 are vertical angles, and 3 and 4 are vertical angles. Complementary angles, there's sum adds up to 90 degrees, so 90. So in this case, 1 and 2 are complementary, and when you have adjacent complementary angles, the whole thing forms a right angle, and you can indicate that with the box. A and B are also complementary because even though they aren't next to each other, 47 plus 43 adds up to 90 degrees. So they don't even have to be next to each other, but as long as they add up to the 90 degrees, they are complementary. Supplementary adds up to 180 degrees. So 3 and 4, they're adjacent to each other. They're going to form 180 degrees, and that kind of forms that line. Remember from last video, this is a straight angle, 180 degrees. C and B actually add up to 180 degrees as well. Even though B is up here and C is down here, if you add 137 plus 43, that adds up to 180 degrees. They don't need to be next to each other. Moving on. So we got this diagram. Let's try to look for a few in here. So adjacent angles. Where do I see adjacent? All over the place. I could call angle AFB. Angle AFB. It's adjacent. We can call it adjacent next to BFC. And we can say and angle BFC. Geez, I could just do angle AFE and angle, let's call it EFD. There's a lot of options here. Those are only 2 of many. Vertical angles. So this might be a little bit tricky. Just look around, but it looks like this angle right here and this angle right here looks like those are verticals. So it's angle AFE and angle CFD. So those are vertical angles. Well, you could also say angle AFC and angle EFD because these look like vertical angles as well. It's a little tricky. Sometimes you gotta look around. Complementary. So complementary, yeah, you've even forgot, it's 90 degrees. Just write those down. You're gonna get them flipped. So we're looking for 90 degrees. What adds up? Well, let's see. This is 62 and 28. 62 plus 28, that's 90. So, yep. So, angle AFE and angle BFC. Complementary. Let's see. Supplementary. Well, looking around, I'd say these 2 angles right here look like it. So, angle AFE plus angle EFD. So 62 plus 118 is 180 degrees. That's supplementary. All right. You can't. Maybe some of these others are supplementary too, but we don't know the measure of these angles, so we can't say that. We don't have that information. We only know the measure of these 3 angles. And so sometimes you're going to given a diagram like the last one where you don't have complete information, or maybe you don't have any information, it's just a bunch of lines and segments and rays. But you can still conclude a few things. For example, you can conclude when there's adjacent angles because they're right next to each other and they share a common side and they have the same vertex. You can figure out angles that are adjacent and supplementary. What's supplementary? Supplementary is the 180 degrees. Because if something's adjacent and supplementary, they're actually going to form a line, and we'll get to that later. Vertical angles. That's easy to see too, because if you have 2 lines going through, this angle right here and that angle right there, they're going to be the same. Same over here. These 2 are going to be congruent. So vertical angles. what you can't conclude, you can't say angles or segments are congruent. I can't say this angle right here and this angle right here are congruent. Even if they look really close, when you eyeball them, I mean, mine don't really look close. Just because they look close doesn't mean they are, because you need information that tells you for sure. Right angles, you can't tell. Like, even if you drew a straight line like this, I might say, yeah, that looks like a right angle, but unless it's actually labeled a right angle, you have some other evidence, you can't just assume it's a right angle, even if it looks close. Complementary, so that's where they add up to 90. Again, you can't. Even if you have two angles like this, and you say, well, it looks like they add up to a right angle, unless you know they actually add up, you can't say that. So here's the definition. Linear pairs and linear pair postulate, these are connected. So linear pairs are adjacent angles whose non-common side forms a line. So we got an angle here. I'll call that angle 1. We got this angle here, 2 arcs. We'll call that angle 2. They have a adjacent side right here, a common side, but the non-common sides are this one and this one, and those actually form a straight line, straight across. Linear pair postulate says if two angles form a linear pair, which these two do, they are supplementary, so they add up to 180 degrees. So that means this whole arc right here is 180 degrees. This is actually a straight line arc, or straight angle. So that whole thing's 180 degrees, half a circle. So this has some neat properties, and you'll see it pop up a bunch in geometry. Angle bisectors. Angle bisectors are an array that divides an angle into two congruent angles. So it just cuts it in half. So in this case, this is our bisector right here, where I starred, and we got an angle right here and right here. And since they both have one arc, that means they are congruent. We don't know what the degrees are, but we know it's congruent. So let's do some examples. Pause the video, try this out. Alright, let's answer this. Ray AC bisects angle ZAB. If the measure of angle ZAC equals 58 degrees, what is the measure of angle ZAB? So we know this bisects this ray AC. So if this bisects and angle CAZ is 58, then we know this other angle is also 58 degrees. But we need to find the total thing, ZAB, this whole angle right here. But we can go back to, I think, the last section where we said we can add these two adjacent angles up if they are adjacent, share the same vertex, and they add up to the whole thing. So our measure of angle ZAB is going to be 58 degrees plus 58 degrees, and that's going to equal 116 degrees. Yep. So that's the measure of angle ZAB, 116. Next one. Pause the video. And let's try this. What can you conclude from the information on the diagram? So there's lots of things. So it's kind of open-ended here. I want to go back to that original chart just as a reminder for me. So adjacent angles. So what do we know that's adjacent right here? Well, we know angle 3 is adjacent to like angle 4. We know a lot of those. We could do tons of those. 2 is to 3, 1 is to 2, and so forth. What else can we conclude? Well, vertical angles. Do we know any vertical angles in this case? Well, yeah. So we can go with vertical angles. I'm going to abbreviate it VA. Are angle 3 and angle 5. Those are vertical. What else can we conclude here? Complementary angles and supplementary. And, well, let's see. I don't know complementary and supplementary because I don't have any information about that. I do know that angle 2 and angle 1 both have one arc, so I can say angle 1 is congruent to angle 2. That's information I could use. What else? I think that's it. There's probably some more. Why don't you try that out and come back to class? And we're done.